All right. Okay, so this is where we left off. Just make this correction right here. Just get rid of this. Okay. All right, so we're given in this one, we're told that the tangent's equal to -2. Okay, so this length is 2. Negative just means it's going downward. Okay, so this is the tangent value right here, that length. And this question's asking, what are the coordinates of that point? What's the cosine and what's the sine? All right. So right now, to do that, we know one way of getting cosine, or one way of getting tangent, which is sine over cosine. Okay. All right, so let's see. Okay, so we know this. We know that by definition, the tangent is equal to the sine divided by the cosine. Okay, and then the other thing that we know is that if you square the sine and the cosine, you get 1. All right, now, we know that tangent is equal to, this is equal to -2, the tangent. So I know this. -2 equals sine over cosine. All right, now, how can I use this equation on the left and this equation on the right here to get the value of either sine or cosine? This is a system of equations. Here's one equation, here's the other. You can't solve this because you got two different things. So is there a way to make both of these cosines or both of these sines and then solve it? Here's, you know this. Yeah. Move these to the other side? Okay. Yeah, but I'm still going to have two different things in there. So here's what you're trying to do. You want to rewrite this so that it only has cosines in it or only has sines. It doesn't have both. Because if this just had cosines in it, I could solve it. If it just had sines in it, I could solve it. So how could I rewrite this so that it only says the word cosine or only has the term sine in it? Knowing this. It's the same strategy you use when you solve a system of equations. Okay, take this and solve it for one of the variables. Okay, so for example, if I took this and I solved it for sine, okay, so I'm going to take this equation and solve for sine, which means I'm going to multiply both sides by cosine. So if I did that, if I multiplied both sides by cosine, I'd get this. Okay? Now, take this and substitute it in for sine. And now you're just going to have the words cosine. All right, so if I did that, I'd have cosine squared theta plus, I'm going to take that and put it in for the word sine. Negative 2 cosine theta squared equals 1. Okay, now we solve this. So cosine squared theta plus negative 2 squared, 4, and then cosine squared. All right, now combine like terms. That's 5 cosine squared theta. Okay, divide by 5. And take the square root. Okay, so cosine theta, square root of 1 is 1, and the square root of 5 we'll just leave. We don't have to rationalize it because you don't have to worry about that in IB. Now, there's a plus root and a minus root. What cosine value is this going to be? The positive or the negative? Is cosine positive or negative here? Yep. Any questions on why cosine's positive? All right. So there's our cosine value, 1 over root 5. Okay. That as a decimal, 1 divided by square root 5, 0.499. Let's see what we had on our drawing, or on our applet here. Okay, 0.44. Okay, but mine isn't exactly at 2. Notice my tangent's a little off. So my answer for cosine's a little off. I don't think I can get that closer. Nope. Yeah. All right. But pretty close to what we predicted using the applet. Okay, now let's do, now you got your cosine. So plug it into your Pythagorean identity and get your sine. Okay, so I'm going to have 1 root 5 squared plus sine squared equals 1. Now we just solve that. So 1 squared, root 5 squared. Subtract 1/5. Get 1 minus 1/5, which is 4/5. Think of that 1 as a 5 over 5. And now do the square root of everything. Square root of 4 is 2. Square root of 5, I can't do. I just leave it alone. Okay, now in this quadrant, since I'm in the 4th quadrant, over here, my cosine value, or my sine value, is going to be negative, because the y is negative. So this would be negative 2 over root 5. And if you converted that to a decimal, you should get the same thing we got on our applet. okay, for the sine value. Okay, I got my sine at 0.89, and when I do this, when I do 2 divided by root 5, okay, I get 0.89. So that was pretty accurate. Okay, with what that and then what we got on GeoGebra. Okay. All right. So now the next part here. Okay, the other day we saw these patterns. We noticed these patterns on when we were working with the different values. So this is the one that says an angle, the sine of an angle and its supplement are equal. The cosine of an angle and its supplement are opposite. Okay? All right, so this was the supplement. These are supplements. That angle and that angle are supplements because they add up to 180. Okay, so those two are supplements, these two are supplements. So the cosine of supplements are opposite, the sine of supplements are the same. Okay, and then the other pattern was this. The cosine of an angle is the same as the cosine of 360, take away the angle. The cosine values are the same. Or pi over 2, which is the same as 360. So all that means, guys, what that one demonstrates, if I opened up, let's see. Okay, this was that other applet that we did. Okay, if I did the cosine of, let's say, 60 degrees. Okay, that's pretty close to 60. Okay, do you notice that this angle has the same cosine? 299. So if this was 60, 360 minus 60 would be 300. They're going to have the same cosine values. Okay, so if I had a cosine of 120 degrees, it would be the same as the cosine of 360 minus 120, or 240. You guys follow what we're saying there? Okay, that's what this part is talking about right here. That's the last one, the last pattern there. All right, so the examples that we're doing here is, it says find two angles on the unit circle such that cosine is equal to 1/3. Okay, now it's asking you for the actual angle. It's not asking you for what the sine and the cosine are. Okay, all right, so let's open up that first applet that's got sine and cosine in it, and set cosine to 1/3. So I don't care about sine right now, just cosine. So I'm going to unclick everything else. All right, set your sine value, your cosine, to 1/3. So that would be like 0.33. There it is. Okay, so the angle that has that cosine is around 70.53 degrees. Now, if you click on show the other angle, click on show the other angle is going to be 360 minus 70.53. That's 289. That's the other angle. So once you find one angle, subtract it from 360 to get the other angle. All right, now to get an angle on your calculator, okay, to get the angle on your calculator, you're going to use what's known as the inverse key. So if you look right above your sine, cosine, and tangent keys, you'll see sine with an exponent and -1, cosine with an exponent and -1, and tangent. Okay, those keys are called arc sine, arc cosine, arc tangent. And we use those to find the angles. All right, so if you put your calculator in degree mode, okay, and now go second cosine 1/3, put in 1/3, 1 divided by 3, 1 divided by 3, enter. There's your angle. 50.5, which is, or 70.5, which is the angle that we got on GeoGebra. All right. Now to get the other angle, go 360 minus whatever that angle was. So 360 minus second answer, and there's my other angle that I got, 289.47. All right, now when you're doing it on your sheet here, the only thing that's different is we're not in degrees, we're in radians, because it says the angles between 0 and 2 pi. Right? So you're going to do the same thing, except now you're using 2 pi, or you're using radians. All right, so if I was doing this on my calculator, so let's open up a calculator again. Now switch over to rads. So go mode, radians. Okay, second cosine 1/3. Enter, and that's the angle in radians. 1.23 radians is the same as 70 degrees. Now to get the other angle, you're going to go 2 pi, whoops, 2 pi, delete, clear, okay, 2 pi minus that answer, second answer, and there's the other angle. So now those are the angles, but in radians. This first one's about 70 degrees, and this one is about 289 degrees. Okay? So that's what you're doing on this example right here. All right, so when we did this on our calculator, in radians, we got 1.23 Okay, so that's one angle. So theta is 1.23. Okay, and then the second angle is going to be 2 pi minus 1.23. Okay, so that has what is it? That's 5.5. Yeah.
Does tangent have two values? For the sine, we do 180 minus first angle, and then for cosine, we do 360 minus the first angle.
To get the same value?
Yeah.
Well, tangent would repeat every pi.
So there's only one value for it?
Yes. There's only one. No, there's two. There's, if I'm understanding your question right.
Because you said it's in like the tangent -2 is in.
Yeah, there would be two possible angles, yes. Yeah, there'd be two possible angles that have a tangent of -2. One of them would be in the fourth quadrant, and then the other angle that would have a tangent of -2 would be up here in the second quadrant. So yes, the answer is yes. Okay. So if we made a sketch of this, cosine of 1/3 was about there. Okay, so that had a cosine value. The x-coordinate there is 1/3. That's what that's telling you. Okay, now this opening, okay, that opening between the positive x-axis and that is equal to 1.23 radians. That's the first angle. Okay. Okay, so if I rotate it 1.23 rads, it has a cosine of 1/3. And if I keep going, it's going to have another cosine of 1/3 right there. Okay, so the second angle is if I kept rotating it, so it starts right here and goes all the way around. Okay. This is going to have a cosine of 1/3, and the angle is 5.05. That was our second angle. All right, so let's do it now with sine. So using technology, we'll use the arcsine key. Okay, so second arcsine okay, and then 3/4, and this is the answer in, let's make sure I'm in degrees. I want to be in radians. Second sine 3 divided by 4. Okay. All right, now and then what do we subtract that one from? From pi, right. All right, so the bell's going to ring here in about a minute or so. So for tonight, guys, because we'll finish up this last one, but you shouldn't have a problem doing these. So do this part of the assignment. And then we'll finish this last couple of examples up tomorrow. And do the other half. Just D point 1.